Good morning to all. This is Andresh from Triple A Branch. So today my topic is about the climate effects on us, infrastructure, the economic on of adaptation for railroad and coastal development. So this is the abstract, the change in temperature, precipitation, sea level, and coastal storms will likely increase the vulnerability of infrastructure across the USA using models that analyze vulnerability impact and adaptation. This paper estimates impact on railroads and coastal properties under these infrastructure management response scenarios: no adaptation, reactive adaptation, and proactive adaptation. Comparing damage under each of these potential responses provide the strong support for facilitating effective adaptation in these three sectors. Under a huge greenhouse gas emission scenario and without adaptation, overall costs are projected to ranges the $100 billion and annually by the end of this century. The first tire adaptation, however, reduced cost by a factor of 10, and the second proprietary tire reduces the total cost across all three sectors to the low the $10 of billion annually. For the rail and road sector, estimation cost for reactive and proactive adaptation scenarios captured a broader share of, including selected indirect costs to rail and road users, and so are constantly about the prior estimated. The resulting highlight the importance of considering climate risk planning and management. Introduction: the climate changes is effective infrastructure system across the USA in far-reaching ways, and impact are projected to burn over time in many regions. In many regions, extreme temperature and precipitation events are damaging roadways and threatening the integrity of the rail system as sea level rises, a storm surge erode and threatening the integrity of rail system. Uh, Integrity of rail system, and these major infrastructure systems are critical and nations economy, security, and cultural, as they facilitate commerce, transportation, as social well-being. Already the US roads and rail systems are exhibiting significant deteriorations with existing problems such as shore erosion, coastal flooding, and water pollution expected to worsen with the climate change. To address these challenges, engine planners suggest a need to adapt the way we operate, maintain, upgrade, and infrastructure assistance. So, despite these challenges, limited literature exists. The quantifies the vulnerability of US infrastructures to challenge in the climate assistance, the potential for adaptive action to migrate these risks. The most of the recent natural climate assistance reinforces this point in multiplex contexts. In the transportation context, the NCA authors note that there are few studies that quantify the cost and benefits from adaptation, and those are exist focus of on individual assets rather than the system, and do not quantify both directed and indirect economic costs of transportation system. Uh, Disruptions in the in the urban context. The NCR author note that while adaptation plans are becoming more common, those those that directly incorporate climate projection into infrastructure design, investment, and appraisal criteria and model building codes and uncommon. As a result, adaptation planning is not always informed by the technical analysis of changing hazard and climate volunteer as assessment. A similar situation exists in the coastal zones where current adaptation plans call for the risk identification, but there is a remain little focus on the cost dependent trade-offs required to successful adaptation. In this paper, we present the results of analysis quantifying impact to three category of infrastructure across the US. The analyses were conducted as part of ongoing climate change impact and risk analysis project, which used a constant analytic framework of social economic scenario and climate prediction as compared the economic impact across the sector and region. The framework and socio-economic and climate input supports the cross-sector companies important and unique feature of Kaira work. So the methods and the data. So it's framework, the railroad coastal property analysis. The present hire an employee of consistent analytic framework to evaluate the impact of climate change under the three alternative infrastructure measurement scenarios: no adaptation, reactive adaptation, proactive adaptation. The sector specifies application of these management scenarios are discussed in the respective sectoral methods section below, but are described here in the general terms, with the term damage defined as the physical maintenance of climate effects for the purpose on the term cost as an economic impact of either repair damage or in the case of purposes, and the term cost as a economic implicant as a economic implication of either repairing damage or in the case of user and indirecting costs of failing to repair the damage. The no adaptation scenario represent a business as usual approaching to infrastructure management which do not incorporate climate change risk into the maintenance and repair discussion making process beyond the baseline expectations. In the reactive adaptation scenario, decision makers respond to the climate change impact to infrastructure but not to action to prevent or reduce or future climate changes. Proactive adaptation scenarios, decisions maker takes adaptive action with the goal infrastructure repairs cost associated with the future climate changes impact. These actions trading higher upfront expenditures for the potential further benefits for all saving. This proactive adaptation scenario assume well-timed infrastructure investment, which may be overall optimistic given that such investment have often time been delayed and underfunded in the past, and because decision makings are and the public and typical not fully awareness of potential climate risks. Finally, framework adopted here largely follows the developed for Melvin etc. for the reactive and proactive scenario definitions, but not the no adaptation scenarios, provided additional use context for the scale of risk motivated actions that would be required to adapted infrastructure in such each sector. The climate projection were selected to be constructed with those used in fourth as a higher greenhouse gases emission scenarios and RCP 4.5 as lower scenario. The RCPs identified that there are total approximate radiative forces in the year of 2100 relatively to the 750. The analysis employed five global climates selected based on the criteria detailed as associated technical appendix. The five models applied here were from the Canadian Center for Climate Modeling and Analysis, the National Centers for the Atmospheric Research, the NASA Goddard Institute of Space Studies, the Meteorological Office, and the Hadley Centers, the Japan Agency for Marine Earth system and technology. The analysis used to period to ensure the result for an single year to do not over or underrepresented the future period for any of these five modules resulting of the 20th year. The 1986-2050 is designed to reflect the current climate condition. The combination of RCPs and the GCMs were downscaled from the native GCM spatial resolution for a 1 by 6 degree resolution covering the contiguous USA. The data set called LOCA. The LOCA data set provides a daily projection through of these three variables: daily maximizing temperature, daily minimizing the temperature, and daily precipitation. Bureau of Reclamation and supplemental materials for more details and downloadings. Projections of SLR and SSS for each RCP are based on the NOAA and SWEET, etc. All analysis reflect adjustment over time for population and economic growth, including adjustments to tariff volume for the rail and road sectors and adjustment to property value for the coastal property sector. Details are provided below and in the supplementary material. So the next is the rail. The estimation, the impact of projected changes in the temperature on the currently existing classes rail network in the use of specifically the work dynamic and the caused by the bulk trade where therefore no modulation, no adaptation scenario. The analysis estimated to the cost of delays in the each scenario along with the capital cost of installing scenarios in the proactive adaptation scenario. The currently analysis expanded to 2017. The roads, our previous analysis on the current US roads network focused on the evaluating the potential impact, the climate change and reactive adaptation scenario in which roads are repaired in response to climate change related damage, and in a proactive adaptation scenario in which roads are protected and rehabilitated to prevent a future impact from climate stressors. The current analysis expanded on this on the work by incorporating the estimates of the cost to road user quantified as a delay cost and vehicle operate cost. No adaptation scenarios in which the decision marks limit their annual spending on repair due to the climate change. The cost to the what they spent historically. We assuming that in making repairs, road managers prioritized repairs related to the damage for from extreme preparations and preparation. In case of where the preparation damage remains, these damage is not currently modeled due to the lack of previous researches on which a damage function can be based. However, it is most cases the remaining resulting the average annual change in the costal in 2050 and 2090 relative to the baseline period under RCP for the three sector across all sectors, and in both time periods the estimated average cost increases the greatest under the no adaptation scenario, lowest under proactive all interfaces types in both time periods. As the national level the result is differ, but in the way of directed reflect methodology improvements outlined in above the borderline scope of estimation impact to refine the climate scenarios inputs for the rail and road sectors. The estimated presented proactive adaptation scenarios has comparable patterns across the time and climate constantly about a factor of 2 higher owing to the inclusion thereof knows just the directional actions but also indirect effects associated with the tariff delays. So this is the and also no adaptation scenarios as in the case of adaptation the use of historic trial guards in the input of examination of SS extended curves and used inputs suggested to that new approaches at a national level. However, the changing on full adaptation result in small and almost negligible, but it affects the scenarios resulting in reduce from there about to 63% to 77% in 2090. So thank you. This is all about the information that has given about the climate change of the US.